This video will be about electron configuration. Now before I begin with this video, I highly suggest you to review over the quantum numbers if you haven't yet, just so that you know what they are, because we'll be using it in this video. Alright, so now let's begin. Electron configuration is it just tells us where the electrons are in an atom using sublevels and energy levels, and so that we can keep track of how many electrons there are in each atom. So I'll begin with an example. With hydrogen as the example, hydrogen atom, we know it has an atomic number of 1. So with an atomic number of 1, it means we have 1 proton. And let's just assume it's a neutral atom. So with 1 proton, we should have 1 electron to counteract the positive charge. How do we write that? There's 1 electron in hydrogen, and what energy level and sublevel it's in? Well, this is how you write it with electron configuration notation. So the 1 states that we're in the first energy level. The S states that we are in the S sublevel, which you know is a sphere, shape of a sphere. So that electrons residing in an area shaped like a sphere. And the 1 tells us that there's 1 electron. So certainly this is the electron configuration for hydrogen. Okay. Now let's go on to a tougher example. So let's try oxygen. So oxygen, we know the atomic number is 8. And with atomic number of 8, how many electrons does that mean oxygen should have? It should have 8 electrons if it's a neutral atom. So with 8 electrons, let's write it out in electron configuration. Alright, I don't expect you to know this if you haven't seen this before. So the electron configuration for oxygen is 1s2, 2s2, and 2p4. Now let's count. 2 electrons plus 2 electrons is 4. There's 4 here. And there's 4 more here. That adds up to 8. So I think this electron configuration is correct because we have 8 electrons now. Okay, so on the topic of valence electrons, how is this so important? Oh, I shouldn't have erased that. Okay, so for valence electrons, how can we use this to find the valence electrons? Well, valence electrons are just electrons that are in the highest energy level. So these numbers here, that's the energy level. And to find out the valence electrons, let's just look at the highest energy level, which is 2. So we have 2 electrons and 4 electrons, which means there's 6 electrons in the highest energy level. And that means oxygen has 6 valence electrons. Okay, so now that you know what electron configuration looks like and how we can find out the valence electrons from it, how do we write it? How am I able to use it for myself? By just knowing the amount of electrons I should have. Well, there's a way, and this is one way you can do it. So these numbers here, they are the energy levels, and you'll just write out letters of the sublevels right next to it, just like this. Okay, so, whoops. Alright, so for this method, to find out how do I know if I go 1s2 to 2s2 to 2p4? Well, oh, and then how do I know that 3s is next instead of 3p or 3d? Well, this method can show you which order you have to write your energy level and sublevels. So what you want to do is draw arrows. So draw arrow like that, and like that, and like that, and then like that, and then like that. So it should all line up like that. Okay, now what do these arrows mean? Well, as we can see, this is where we start off. We start off from up here. So our first energy level, we want 1s. And we know that in the s sublevel, there should be 2 electrons maximum. So let's just keep going to fill all the energy levels. So the second one, we have our second arrow here. We'll only go 2s. So there's 2 electrons there. Next one, we go back up to p, and we go 2p. We know p contains 4, 6 electrons. Contains 6 electrons. And then we go 3s next. And then we go back up to the top of the arrow right here. So that means we have to do 3p next. And then 4s. We don't go to d yet. We go 4s next. And now we go to d, to the top of the arrow. D. This is 3d10. And then we'll continue on here. 4p6 right here. And then 5s2. Then back to the top of the arrow. We have 4d10. And then 5p6. And then 6s2. Then top of the arrow again. 4f, I think f has 14 electrons, if I'm not mistaken. And then d5, d10, 6p6. Okay, so I think you kind of get it. So every time you reach the bottom of the arrow, you go to the next row at the top of the arrow, and you go down to see what hits the arrow first. Like for here, so I'm done with 3p, 4s. I go back to the top, 3d, 4p, 5s. Back to the top, 4d, 5p, 6s. And that's how you know whether to write 1s or 3p. That's how you know. Also, another trick that I've learned is using the periodic table. And it's pretty easy. So, I'll bring up the periodic table. So here is the periodic table, and I'll tell you how I use the periodic table to figure out electron configuration. So the periodic table looks something like this. So everything in the black, that's the S sublevel. Everything in the red is the D sublevel. And everything in the green is the P sublevel. And there are numbers on the left over here. And these numbers represent the energy level. And there are numbers up here, and these numbers represent the number of electrons. And I use this information, especially during tests when I forget about the pyramid technique, to figure out the electron configuration of an atom. So how do I use this? Before I continue, one thing to note, for the D sublevel, whatever number you have on here, the D is minus 1 energy level. And I'll show you in an example later on. But first, let's use this technique. So let's try to figure out the electron configuration for argon. Now, I have argon already put up. And argon has 18 protons, which means it has 18 electrons if it's a neutral atom. So let's begin. We'll start off with the first energy level in the S sublevel right here. So we have 1, then we go over here 2. That is 1s2. And then we'll go down to the next energy level. The S sublevel again. 1, 2, 2s2. And then the P sublevel. P, 1, 2, 3, 4, 5, 6. So 2p6. And then to the third energy level, 1, 2, that is 3s2. And then to the P sublevel, 1, 2, 3, 4, 5, 6. Now we're at argon. So 3p6. And that is argon. So let's count. There's 4 here. And then that makes 10 electrons. Oops, sorry for that. 10 electrons. And these two make 8, which equals 18 electrons. So this is a good electron configuration. This is the correct electron configuration. So now we know how to figure out electron configuration using the periodic table. Let's keep going. Let's go practice the D sublevel. So let's go to try gallium. So we have argon already, which is over here, and we can just continue on with the electron configuration that we already have. So let's go on to the fourth energy level. So 4s2. And then here we go to the D sublevel, and since on the left there's the number 4, we remember the D sublevel is 1 less than that number. So we're in the 3D sublevel, and let's count the electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 electrons in the D sublevel, and then gallium is in the P sublevel in the fourth energy level. So 4p1. And this is the electron configuration for gallium. Maybe you don't want to write all this. So how can we make it easier for us? We already found out argon, and we know argon is this right here. So what we can do, we can substitute all these S and P's for just argon. Just like that, with the brackets. And then we continue on the electron configuration. Oh, whoops. And this is another way of writing the electron configuration for gallium. So now imagine they did not tell us this was gallium. they only gave us this. That's all that they gave. And they're asking us, what is this atom based on how many electrons there are? So for argon, we'll assume it's a neutral atom. So argon has 18 protons, which means there are 18 electrons. 18 electrons in argon. Now let's count off the rest of them. There's 2 here, 10 here, that's 12, and then 1 over here, which makes it 13 electrons. So this equals to 31 electrons. Now with 31 electrons, and let's say the problem says we're looking for a neutral atom, well, that means there are the same amount of protons as electrons. So we can deduce that there are also 31 protons. And protons tells us the atomic number. And what is the atomic number, or what is the element with atomic number 31? That is gallium. So that means we can find out an element using the electron configuration